Is 1,3-dithiane part 2 Woodward and prevost reagent. So moving on to applications of 1,3-dithiane part 2. In that application, here in the continuation thing we have left with certain applications. So we have earlier said that it is 1,2 adduct and 1,4 adduct formation. So we are showing 1,2 adduct intermediate. So how it will work out? So in the 1,2 adduct intermediate, if we'll take this one and then if we'll take this compound, and when it is treated with HCl, it undergoes rearrangement, and once it will undergo rearrangement, like this group OH groups comes towards this side, this bond shifts, and then at that time what happens, you'll get the more stable complex. Once you'll get the more stable complex, if you will treat it with HGO, that is you are deprotecting this molecule. 1,3-dithiane gets deprotected, leading to the formation of your carbonyl compound and then resulting you in this structure. And after that you have to do the oxidation, that is upon addition of MnO2 manganese oxide, you will get back the OH group gets converted into double bond O carbonyl group, that is your ketone group. And then moving on to next reaction, if you will see in the reaction with the nitriles, you are taking the anion of 1,3-dithiane and it undergoes the nucleophilic addition reaction and resulting you in the dicarbonyl compounds. If you will see here, if you will take the 1,3-dithiane anion of 1,3-dithiane and then if you will treat it with the nitriles RC triple bond N, the minus charge, the anion of the dithiane goes and attack to the carbon atom of your nitrile group. Once it will go and attack, and then the bond which is present between the carbon and nitrogen, the triple bond, one of the bond will shift, make it as a negative charge, leading to N minus ion. Okay, once you will get the negative charge in the nitrogen atom, and then if you will treat it with the butyl lithium, at that time lithium will come and sit over there, and then upon hydrolysis on heating, in this whole group gets converted into the oxygen atom. Okay, and then again if you will treat it with the HgCl2, in the presence of mercury, what happens? Water and CH3Cn, and at that time deprotection takes place, is resulting you in the dicarbonyl compounds. Moving into next application, reactions with the acid chlorides. You are taking the acid chlorides and again you are treating it with anion of dithiane. Okay, 1,3-dithiane. So this anion again goes and attack to the carbonyl carbon of your acid chloride, right? And then once it will go and attack to the carbonyl carbon, this is nucleophilic addition reaction, and then this gets cleaved out, the chlorine will get cleaved out, resulting you in this structure. After that again one more anion of 1,3-dithiane goes and attacks to the carbonyl carbon, and once it will go and attack, the carbon and the oxygen bond shifts, make it as a negative charge O minus, and it abstracts the proton on upon addition of the H plus protonation, it will abstract the proton, resulting you in the dithiane. Two molecules of dithianes will come and attack to the one of the carbon atom. If you will deprotect in the presence of HgCl2, okay, if it deprotects, at that time what happens, simultaneously both the group gets deprotected, resulting you in the this C double bond O, that this is an aldehyde molecule and this is one more aldehyde, so it is like gem aldehyde, gem dialdehyde molecules you will get. In the reaction with the carbon dioxide, so again you are taking the anion of 1,3-dithiane and then you are treating it with the carbon dioxide, solid carbon dioxide, you will get back your alpha ketoacids. So here the anion goes attached to the carbon dioxide carbon, which is electrophilic in nature. Once it will go, this bond shifts, make it as a O minus. Here you are treating it with butyl lithium. Okay, so lithium atom comes and sits over there, bind over there, and then when you will do the hydrolysis, upon hydrolysis, yes, it will go it as LiOH and H plus goes and sits over there. It is just abstracting the proton from water molecule with the cleavage of LiOH. And after that, once you will get back this, your thing is to do the deprotection. So if you have to do the deprotection, you have to add, if you have to treat it with the metal such as mercury chloride or cadmium carbonate, CH3CN, and so on. Upon that addition, what happens? This whole group gets deprotected, dithiane gets deprotected, resulting you in the carbonyl compound. So you will get RC double bond O COOH, that is your alpha keto acid. So next thing, only if you will think like carbon is only acting as an electrophile, it's not that easy. So you are having one more electrophile also, that is your silicon atom from the TMSCl. We have studied TMSCl in the earlier classes. So from that TMSCl, electrophile is silicon atom is also acting as an electrophile. So you are taking the 1,3-dithiane, and then once you have to treat it with the, when the 1,3-dithiane gets treated with the butyl lithium, you will generate the anion of 1,3-dithiane. This anion goes attached to the silicon atom, which is electrophilic in nature. Meanwhile, there is a cleavage of Cl. That is your SN2 type of reaction is taking place over here. Simultaneously, there is attack of a nucleophile and there is a cleavage of your leaving group. So you will result in 2-trimethyl silyl 1,3-dithiane. Okay. And after that, you have to do the deprotection. You have to treat it with HgCl2. Once you will treat it with HgCl2, you will result in the carbonyl compound. In the next application, that is you are taking the formaldehyde and then you are treating it with the TMSCl, and you are seeing which product you will get. So if you will treat it with the formaldehyde in presence of TMSCl, you will get alpha beta unsaturated carbonyl compounds. Okay, so you are taking the formaldehyde, and first you will treat it with the dithiol propane 1,3-propane dithiol all upon BF3 addition, and you will get back your this moiety, that is your 1,3-dithiane, and then again if you will treat it with the butyl lithium and TMSCl, at that time what happens? First it will generate the negative charge. Okay, butyl atom will go abstract the proton, it will generate the anion. On that anion will go attack to the silicon atom. Meanwhile, there is a cleavage of your chlorine moiety and then chlorine molecule, and you will result in this structure. Upon addition of RCH2CHO, that is your aldehyde molecule, aliphatic aldehyde, if you will treat it with this, that time what happens? Here this molecule go and attack over here, and then you will result in an alcohol. Okay, so once this upon oxidation, you will get back your alcohol molecule, and again upon addition with the KH or BF3, at that time this bond which is present between the carbon and TMS, at that time this bond will shift, make it as a double bond, and then there is a cleavage of OH group as well as SiMe3. SiMe3OH group will get cleaved out, resulting you in this structure, that is your double bond alkene formation is taking place over here. And then upon treatment with the BULI, that time what happens? This butyl group will go abstract the one of the proton from CH2 group, CH2R group. So one of the proton gets cleaved out, generating it as the carbanion. Once it will generate the carbanion, this carbanion will shift, make a double bond. Again there is a shifting of this bond towards this side, make it is like a resonating structure over here. It is canonical form, another canonical form gets back over here. So once you will generate the minus charge towards this side upon the dithiane, and so this negative atom will go and attack to your alkyl group with the cleavage of your halide moiety. That is your SN2 reaction which is taking place over here, and after that if you will get back this structure, so you have to treat it with the deprotection takes place over here upon addition with the HgCl, resulting you in the alpha beta unsaturated carbonyl compound. Moving on to prevost reagent. So prevost is a scientist who discovered this. So prevost reagent is nothing but it is a solution of the iodine in CCl4 or in the equimolar amount of, okay, I have used this short form over here, equimolar amount of dry silver acetate or dry silver benzoate. So this takes place in the anhydrous condition. What is the main aim of this is, when an alkene is treated in presence of this iodine in CCl4 or dry silver acetate or dry silver benzoate, in presence of this molecules, in presence of this reagents, when an alkene is treated, at that time there is a formation of trans glycol, which upon saponification results in the trans diols. This is about the mechanism part. You can go through. In the mechanism I will explain. So let's begin with the reaction. So you are taking the cyclohexane here. So if you will take the cyclohexane, you have to think that this is your main aim is whenever you will see this reagent, at that time you should remember when an alkene is present, that time it will leads to the formation of your trans product. Okay, so when an alkene in presence of iodine and silver acetate, it upon acidification, hydrolysis, what happens here is there is the formation of your trans 1,2 dihydroxy cyclohexane. Moving on to mechanism. So in general you are taking an alkene and then if you will treat it with AgI, that is first you have to treat it with iodine and then silver acetate. Okay, so first thing what happens here is the alkene bond which is present over here, double bond of the carbon carbon, this bond goes attacks to the iodine, this iodine again goes, that is your ankymeric assistant, that is neighboring group participation. Okay, once this goes and attacks over here, that time there is a cleavage of one of the iodide with the Ag plus. Ag plus will take the I minus and it will go off, and this acetate ion will be there itself. So then in the next step, first you have to generate the iodonium ion salt. Okay, after the generation of the iodonium ion salt, there is the attack of a nucleophile of an acetate ion. Okay, so this acetate ion, the oxygen atom which is having the minus charge, will go attack to the carbon atom. Meanwhile there is a cleavage of the one of the bond, resulting in this iodoacetate, that is neutralization of the positive charge which is taking place. Okay, and then you will lead into the iodoacetate molecule. So after that there is an intramolecular SN2 reaction. So here the arrows is not visible clearly. So here if you will see the oxygen which is having a lone pair of electron, this goes attacks to the carbon atom, next adjacent carbon atom. Okay, first you are attacking towards your right and then towards your left. So this attack of the oxygen atom, lone pair of electrons from the oxygen atom towards the carbon atom, and then there is a cleavage of your iodine, that is your iodide gets cleaved out from your iodoacetate, that is your intramolecular. Within the molecule the reaction is taking place simultaneously. The attack as well as cleavage of the living groups takes place simultaneously. Okay, leading you in the oxonium ion formation. After the oxonium ion formation, there is the attack of one more molecule of your acetate. Okay, the oxygen atom again goes attacks to the carbon atom. Meanwhile there is a neutralization of the positive charge from the oxygen atom. So once it will gets neutralized, you will get the transacetate product. Transacetate product you will get. Remember, after the formation of transacetate product, upon hydrolysis, what happens here is this whole acetate molecule which is present over here, this goes as CH3COOH. One of the H atom will come and sit over here, and then this will go as CH3COOH, and then here also CH3COOH. With the cleavage of the acetic acid, you are resulting in the trans 1,2 diol. And here again there is two things. One is you can show it in the resonance form. So you can, if it is not cleaving out, okay, if this part is not cleaving out, if we are not attacking with any of the acetate ion. At that time what happens, only if the neutralization of the oxygen atoms takes place, means at that time there is a formation of the carbocation. This will take place in the Woodward synthesis, that is your synthesis of the cis diols. For the remember always, for the prevost there is a trans 1,2 diol product, so you have to attack the acetate ion. This step you have to follow. For the prevost you have to follow this one. For the Woodward you have to follow after the resonating structure, which I will show you in the upcoming slide. In the Woodward synthesis, in the Woodward reagent, what you have to study is, Woodward reagent is nothing but it is a solution of the iodine and silver acetate or silver benzoate in the equimolar amount in the presence of the moist acetic acid or KOH. Okay, in the presence of these reagents, that reagent is known as Woodward reagent. Okay, so here what happens, the alkene gets converted to cis 1,2 diols. Okay, so moving on to reaction, the same thing happens, the ankymeric assistance by the acetate group, and it forms a powerful bonding. It has a powerful bonding capacity of the silver ions for the iodine, which gives the cyclic acid oxonium ion. Okay, so here if you will see, if you will move on to the reaction, if you will see here, you are taking the same thing like alkenes. Okay, and then here reagent will vary. In the moist condition, if the KOH and ethanol is present upon the addition of the acetic acid and silver acetate or silver benzoate, upon acidification, means it is this cis diol product is formed. In the mechanism, so again you are taking the alkene. Okay, same thing which I have showed you earlier, like in the prevost thing. Till here the same mechanism will take place, please go through. And then after this formation, what happens, after the formation of your oxonium ion, once your oxonium ion is formed, at that time there is a resonating structure. Yes, so what happens here is, you can see, please don't put this arrow, this, it is like a mistake over here. This arrow, this bond is neutralizing the oxygen charge, positive charge. Once it gets neutralized, at that time there is the attack of the water molecule. Please don't consider this arrow mark. Okay, sorry for this mistake. Then you have to treat it with water molecule. Again the water molecule, which is oxygen, which is having lone pair of electrons, goes and attack to the carbonium ion. Okay, carbocation, and after that it will form one more bond of like OH2 plus. Okay, so after the formation of OH2, then with the deprotonation, what happens here is, you will result in OH molecule here. After the formation of OH molecule, this OH bond which is present over here, this bond will shift, resulting you in the carbonyl compound, and then there is a cleavage of the one of the bond towards your oxygen atom, resulting you in the O minus. Okay, the O minus will again abstract the proton, resulting you in the alcohol form, and then you will get back this structure. Again, if you will do the saponification, upon saponification, what happens, this whole group, that is your CH3CO and OH will get cleaved out. One of the H atom will come and attack over here. In the water, if you will see H2O, right, so OH will go and it will cleave out as the CH3COOH, and one of the H atom will come and bind towards your oxygen atom, resulting you in the cis diol product. Thank you. If you have any doubts, you can ask me in the comment box. Like and subscribe my channel.